In April 2008, a discovery was made in South Africa that sent shockwaves through the world of paleontology. Lee Berger at the University of Witwatersrand in Johannesburg, with a bit of help from Google Earth, made a life-changing discovery. In a shallow pit, he uncovered the remains of two hominids, a young adolescent male and a mature female, and they had features that provide the missing links between earlier Australopithecines and Homo erectus, our immediate ancestors. They're a totally new species, which the team have christened Australopithecus Sediba, with Sediba meaning natural spring in the local dialect. This week, Lee and his colleagues internationally have published their discoveries on Sediba in the journal Science, and he kindly agreed to grant to me a privilege which has been shared by very few people around the world, and that was a chance to experience the fossils for real in the flesh.
These are the two most complete early hominid skeletons that have ever been discovered. They belong to a new species that my colleagues and I described, Australopithecus sediba. It sits at about 1.95 million years old, and we've argued that it makes a pretty good transition between the early Australopithecines, Lucy, Mrs. Ples, things like that, and our direct ancestor, Homo erectus.
How did you find these?
They were found in sort of a eureka event, but at the same time they were part of a very long process. I'd been exploring this region outside of Johannesburg that we call the Cradle of Humankind, a UNESCO World Heritage Site, for the last 18 years or so. And in the 1990s, I had conducted a survey of the area using technology available at that time, aerial photographs, relatively primitive satellite imagery, and very expensive handheld GPSs at that time. And I had mapped out all the caves we did know, as well as found some new ones. I found about 30 new caves and about 4 new fossil sites. I thought this was pretty good in an area that's probably the most explored area on planet Earth for early human origin remains. And it kind of stalled at that time because I thought I'd discovered it. In Christmas period 2007 going into 2008, I was probably the last human being on Earth to discover Google Earth. And I did just what everyone does when they first find that amazing freeware. I looked at my own home, see if you're lying naked by the swimming pool. And then I put in places I knew. And of course, I had all these wonderful GPS coordinates. And I put them into Google Earth and flew into these locations, and they were all wrong. Every single one of those GPS coordinates was wrong. They were, the dots, the place I flew into was anywhere between 50 and 150 meters away from the actual locality. I would very quickly find out, of course, that's because the U.S. governed satellites at that time had built-in error in them. So terrorists couldn't, fly airplanes or missiles into buildings. And when the French put up satellites, they deregulated that error. So all my coordinates that were so carefully collected were wrong. But what was remarkable was I could move the coordinates onto the caves. I could see the caves. They appeared as blotches of trees. They appeared as small shaded areas. But in every circumstance, I could see them. And when I looked at the big picture, I suddenly could see patterns in it. And that made me realize that it looked like there were more. Now, I knew there weren't because I'd done this survey before, but it was intriguing enough that in March of 2008, I began a walking survey, literally with my laptop live on 3G, a printed A4 of target areas, starting just outside of Joburg, as far away from where I was currently working as I could, because I knew that area better than anyone else. And on the first day, I found 21 new cave sites that no one else had ever seen before. By July of that year, 2008, I'd found 600 new cave sites, 30 new fossil sites. On the 1st of August, I found this site, Malapa, 1.5 kilometers from where I've spent the last 18 years digging at the site of Gladysville.
Why are caves so important? Why were you focusing on them?
Well, in this area, there are dolomitic limestones. And the dolomites are karstic. They contain caves. Those caves, once sediments or bones get in them, they literally cement together. So they fill with concrete, effectively. And the area is literally littered with cut through like Swiss cheese, like a big block of Swiss cheese. And we're going through looking at sections of these ancient cave systems. I found the cave on the 1st of August. I found 46 other caves that I'd missed on that same day in the immediate vicinity. Went back on the 15th of August with my 9-year-old son Matthew, my postdoctoral student Job Kibbe, and my dog Tal. We arrived back at the site. I said, okay, guys, go look for fossils. And with that, Matthew and Tal run off the site. I think I'll see them at lunchtime, middle of a game reserve. I was standing there looking at this little pit in the ground, and I was explaining to Job that I thought miners had possibly not destroyed this cave because they'd found all these other caves. And Matthew said, Dad, I found a fossil. And I knew immediately what he'd found. I didn't even have to look because I knew he found an antelope fossil because that's all we bloody ever find. We find about 500,000 antelope fossils for every one of these early human fossils. I think, as anyone would know, these are the rarest sought-after objects on Earth. There are probably just a few thousand fragments have ever been found in all of history, and I didn't expect that. But he's your 9-year-old son, got to support fossil hunting. I started walking towards him 5 meters away. I knew exactly what he'd found, and I knew his and my life were going to change forever. Because he was holding a little rock, if you imagine something about twice the size of a rugby ball, and sticking out of the front of that rock was a hominid clavicle, the collarbone.
Is that amongst this collection?
It is. It's right here. And what was sticking out was this little blackened area that I've got in my hands. And I knew instantly what it was. Firstly, very few animals have clavicles in Africa. Bats and moles, it's clearly too big.
So it's got to be a mammal.
Yeah, absolutely. Yeah. Well, it's not only got to be mammal, it's got to be one of 3 kinds of mammals. Either a bat, a mole, which it wasn't, it was too big, or a primate. And amongst primates, most primates have a sort of L-shaped clavicle. It's very straight. Hominids have an S-shaped clavicle, a sigmoid-shaped, and you can see the curvature that I could see almost instantly. And I'm one of the world's only experts on hominid clavicles. I did my PhD on them.
Isn't it extraordinary that the one bone that your son managed to pick up first to find this was the very thing you know about the most?
Absolutely. It gets better because there have been almost none discovered, never a complete one before. I did my PhD on the clavicle, the proximal humerus, and the scapula, of which no complete one of those bones had ever been discovered in the early hominid record. I was looking at that block that he was holding. My son said I cursed. I don't believe that. I turned the back of the block over, and there was sticking out the back was a hominid canine. This one right over here, and the jaw.
I can see why you got excited.
Well, there was nothing else it could be. It was as if it was hardly even fossilized. It was sticking out so beautifully. It's small. It was clear that it wasn't primitive, and that stunned me almost immediately.
And this is 1.95 million years old.
It was. We wouldn't know that at the time, but we would find that out very rapidly because this was discovered, of course, as part of a survey project. And I had a whole bunch of geologists on tap. I mean, literally within days we would have them there. That would turn out to be, in that block, the part of the upper skeleton of a child, about 13 years old in developmental terms of humans, that would eventually become the holotype and would eventually reveal this extraordinary skull that you're looking at right here.
Staring at me out of this case is a very complete skull. Is that the most complete?
It is arguably the most complete early hominid skull ever discovered. You can see it's effectively undistorted. You can see every muscle marking on it. It is a beautiful, beautiful object in and of itself.
And there's a complete cervical spinal column.
A complete cervical spine down to the thoracic vertebra. The lumbar vertebra are beginning to come out. You can see some ribs that are beginning to expose. What you're looking at, the 30 or 40 bones that are in front of you right now, are really just a work in progress, because almost every day in the lab, or at least once a week, someone brings up another part of this child. His left side is largely still out at the site, and we're working our way through that. If this had been all we found, it would be, it'd be in the top 5 discoveries ever in paleoanthropology. You are looking at the most complete associated skeleton of an early hominid ever discovered, but of course it wasn't. We had to stop after that first discovery. I had to get a permit. I had cell phone coverage at the site, of all things. Called the South African Heritage Resource Agency, got permission to take the blocks out. Over that week, we were prepared. Everyone was very excited. On the 3rd of September of 2008, I was told we could go back. I was getting the permit. And everyone with a PhD in anthropology, biological archaeology, or who liked dogs, went back out there to look, because I think it was in everyone's mind that if a 9-year-old can find this in a minute and a half, this must be your chance. Because I think, as you know, Chris, we don't find these things. Most people who do what I do go through their entire careers and never find a fragment of one of these even in the wild. We arrived back at the site on that morning. 3 hours later, we hadn't found a single piece that you could associate with an early hominid. And we were devastated. Everyone broke for tea. I was standing next to this small pit in the ground, looking down into it, and I was trying to visually reconstruct how these miners would have taken a little block and thrown it off 15 meters out of the site. I was trying to visualize them in my mind. You know, they were there 110,
because that pit was made by mining.
It was, but it's only 2.5 meters by 2.5 meters. For some reason, they didn't destroy the site in the way that they have destroyed all others. And as I was sitting there staring at the back of that wall, the light reached it just enough, and I could see a proximal humerus of a hominid sticking out of the back of that wall. Now, we'd all been in that pit dozens of times. I don't know how we missed it, but there it was. I did my PhD on them. I know what they looked like. I crawled down into the pit, walked over towards it, didn't say anything to anyone at that point. And as I got closer, I realized that there was a scapula in articulation with it. And I still didn't say anything to anyone. I put my hand on the wall, probably to steady myself, if I'm being honest, and 2 hominid teeth fell out into my hand. And that's when I called everyone. No one could believe it. We got down there. And it never crossed my mind that that was not the child. Because, of course, he had a jaw, a collarbone, a proximal humerus, the shoulder blade. We had the whole shoulder girdle.
Oh, so you just thought it was a bit more of the one you were planning.
I thought it was him.
Now there's another one.
But it wasn't him. It was an adult. It was an adult female. It was a second skeleton. We would later find him lying about 40 to 50 centimeters above her. And what you'll see as we look at her, she's in many ways almost more extraordinary than he is. Now he has that cranium. She will too, very shortly. It is literally just a matter of finding that cranium by scanning blocks and looking into the ground that we'll find. But
if I could ask at that point, so because what I'm looking at here are, and I've just caught sight of a hand.
But only hand.
But we'll come to that in a minute. But these bones I'm looking at are all nice, clean. I can see exactly what they are. They don't come out of the ground like that, presumably.
Well, they do. What they are is preserved in a concrete-like substance. Most of the caves here in South Africa have what we call breccias in them, which is a very hard concrete-like rock. This, because these fossils were preserved underwater, about 30 to 50 meters below the surface at the time, 1.95 million years ago, they are actually in what we call a calcified clastic matrix. It's literally just cement. And the reason their condition is so good is because as our preparators take them out, they have been protected and preserved, and they probably also had fresh organics around them, i.e. flesh around them. And that in some ways helped preserve them in that cementing process. And they're in articulation. I can take you over here and show you actually how they look like as they're coming out of the rock. So there you can see now the scapula here, this large flat bone, the humerus, the radius and ulna. Each of those bones, the only complete ones ever discovered in the entire early hominid record, in articulation, her right side. What you couldn't see in this cast that we had made here as it was being prepared out is that the whole hand was lying under here. We didn't even know that at the time.
You have to chip this concretey stuff away.
You do chip it away. Chip is a sad word for what's a very technical process.
Scratch with a knitting needle?
Done by, not scratch with a knitting needle either, but done with a small hammer-type drill implement that actually uses the differential density of the rock to the bone to flake the rock away, leaving the bone untouched under microscopes. This collection of around 200-odd bones that you're seeing here is the product of probably about 14 or 15,000 preparation hours. It's an extraordinarily interactive team. And one of the important things about this find is that the group studying it is probably one of the largest paleontological or archaeological projects in history. There's over 70 scientists and researchers involved in this project from all corners of the globe, a whole suite of technicians involved. That's one of the reasons we were able to get it out, at least in scientific terms, relatively quickly. We actually put out the description of a new species in 2 papers in Science on the 9th of April, 18 months after the discovery of the site itself.
So let's return to the female then.
Yeah.
So talk us through what we've got here.
Well, we're going to start down at the bottom and walk our way up. She's seen in these pelican cases. These are fire retardant cases. They sit inside of these fireproof vaults that we keep them in, because these are some of the most precious, rarest things on Earth. But you can start down at her foot, and I can show you something that's just mind-boggling. The first articulated ankle.
Oh, yes.
That's ever
I can see.
been discovered.
That's amazing.
There it is.
You can see the calcaneum, the heel bone.
The calcaneus is here. And what's beautiful about this is, it's still complete. It's literally still as if she was taking a step. And the reason we can leave it is because with modern technology, we can scan that and, of course, create each one of these bones. And now I'm holding those individual bones made in plastic, so that scientists can study them, but we can leave
you'd scan that using imaging techniques and then get a plastic replica made.
And made it with a 3D printer.
Which means scientists all over the world can now have a version of that to study without having to damage the original.
That's exactly right. And we can share that data instantly, which is what we're doing. Even better is we can preserve what might be soft tissues and organics, things that we can't actually even anticipate being able to study with technology today that might be in there. We can leave that for future scientists 100 years from now, 1,000, 10,000.
That's presumably going to be really important because it'll tell us about how this person got around.
Oh, absolutely. That is a critical area. It's just as critical as, of course, what I'm picking up right now, which is one of the only articulated knees that's ever been discovered. There's the distal femur. Here we can get the top of the tibia, then I can put it back in place, and there you can see it in place. And, of course, what's that sitting right on top? The first patella.
Kneecap, yeah.
The first kneecap that's ever been seen in the early hominid record. So as we move up the body, the only reason that shaft is missing is just a matter of time. It's literally a matter of us preparing it out. Here you can see the top of the femur as we move up the leg. You can see the fibula in place, and then we move to something very precious. What you're looking at here is the first undistorted pelvis that's ever been discovered, all the way down to a pubis that articulates together, just like I'm doing right now with the real thing.
And that angle where those two bones meet must be able to tell you a lot about you can sex the skeleton from that, presumably, for a start.
We can absolutely sex. Luckily, we have two pelvises. Of course, we actually knew before this pelvis came out, or we hypothesized that this was a female. This pelvis now proves it. And a pelvis that is somewhere between those early Australopithecine pelvises, like Lucy's pelvis, and ours. This looks
so
like
what you're saying, Lee, is this person walked upright?
This person not only walked upright, but they probably were a pretty good striding terrestrial biped. And then, of course, the next box holds a treasure that no one knows about. So you're not allowed to tell anyone, Chris.
That is amazing.
You're looking at the right hand and part of the left hand.
Not just a hand, but every single bone, including all of the wrist bones and the bones right at the tips of the digits, is there.
That's it. You're looking at the first individual's hand ever discovered in the early hominid record. And I don't even have to hint at what we're going to learn there.
Those bones are roughly, knowing what I do about anatomy, those bones are roughly the same size as the ones in my own fingers. This would be a hand roughly the same size and dimensions as my own.
Yeah, not far off.
Longish thumb.
Not far off. Yeah, the thumb's a little bit longer, but not much. It's a little bit more petite than yours would be, I think, but it's not far off, and that's extraordinary. It appears to be at first blush, very much like a human hand. But that's not all, as they say, as we move to the next.
There's more to come.
If you move to this next box here, you can see things that really we drool about as paleoanthropologists. Here is the first complete undistorted ulna. Now we're moving to the bones of your forearm that's ever been discovered. Associated almost directly with it's, of course, radius, which is just in spectacular condition, which articulates as you move up your arm to the bone of your upper arm, the humerus, which has a small fracture in it. And that fracture is very interesting because I think it's going to teach us something about how she ended up here.
So that fracture didn't happen post-mortem?
It didn't happen long post-mortem, if it happened post-mortem at all.
Because there's no healing visible, though, is there?
No healing.
The bone hasn't reacted.
Right. And it's not a sharp break in the way that you look at some of these other breaks, which were done during the process of extraction or done by the miners themselves. There's a left and right side emerging. You can see the left proximal humerus and versus the right proximal humerus. If you're very sharp, you'll notice it's a little bit larger on the left-hand side.
So this was left-handed?
That's the hypothesis at this time, that she's in fact probably left-handed. You see the acromion and the glenoid cavity of the scapula, and a truly extraordinary thing, something that truly hasn't been seen before, the body of an entire scapula. Now, when you think of that, this is paper thin. There's that old Monty Python thing, it's wafer thin, right? Yeah. Well, it truly is wafer thin.
That's why you've left it with that bit of rock around
it
for
right,
for
to actually
support.
Protect it and support it. And again, the beauty of modern technology allows us to extract it.
Extract it electronically. You can scan that, and you can see, as though the rock weren't there, build a cast.
And share it with everybody without having to damage the original, saving that for future scientists. Top of that, seen on the back of that, is, of course, the manubrium. First one ever discovered, of course.
So this is what sits at the top of your sternum.
That's
it's where
right.
the notch is.
That's
if you feel down on your own neck, you feel
That's
that.
That's right. It's that flat bone in the center of your rib cage. If you tap yourself in the center of the chest. And here's something, of course, very near and dear to my heart, the first complete clavicle ever discovered. Given that, allows us to create that whole upper triangle. And you can see that she's got a large part of her rib cage, and over here is a model of us reconstructing her rib cage piece by piece as it grows up to her mandibles. And as I put them here, you look that, well, at first...
more teeth than I've got.
Well, maybe better condition than yours.
Oh, come on.
You are English, right? The teeth are big-ish, but they're extraordinarily small for an early hominid. In fact, these teeth are not far out of the range of what you'd expect in a modern human. And that's something special at 1.95 million years. And you notice I'm not showing you the skull, but if you come back here within a year and a half, if you're a betting man, I would bet you that you will see a skull. It's really just a matter of
So it's in a block somewhere that's
it's in a block, probably in this lab already. We're scanning those blocks, looking into them, trying to see the future, because we've started a program of looking inside of these blocks using x-rays that are allowing us to actually find these fossils prior to actually touching the block. It both saves preparation time. It also allows us to make choices about what we take away, because processing is a destructive process, and what we leave for future generations of scientists.
So just returning to the...
This is the holotype. This is the child.
This is the child that you found first.
Yeah. He's a 13-year-old skull.
So can you just talk us through this skull?
Okay, well, you can see there's some very strange things about it. The first thing that you probably notice is how small it is.
Yeah.
And it is very small.
Not just because it's a child.
Not just because it's a child. In fact, anything but. In fact, at this stage, he's going to be 98% complete. That's not going to get much bigger than that. But the big differences between it and early hominids, and I'm holding here a cast of Mrs. Plez, you can see that they have very poorly developed frontals, pinched behind the eyebrows.
Mrs. Plez being an Australopithecus, what, 3 million?
Africanus, about 2.1 to 2.5 million. They have very flattened faces. Their nose going on. When you look at his nose, you can see that he's developing a real nose. He's actually beginning to project in this area. He's got that wide top of his head. And
big brows.
Big brows,
yeah.
Kind of reminiscent of what we sometimes describe as Homo erectus type brows. The sides of his head, along the temporal, just above your ears, are very straight and flat. In Australopithecines, they curve outward, creating this sort of flared look. And of course, you're seeing a whole skull seen in rock right here. We can look inside of it and see this.
So you scan this, you work out what's on the inside of that bone without having to touch it.
Absolutely, and of course, because your brain is sitting there pumping away with every heartbeat you have, forming a picture of itself on the inside of your skull, we can take the inside of that skull and create effectively what I'm holding here, an endocast.
So that is what the brain would have looked like were this alive now and we'd taken the brain out.
That is his brain, and it's about 420 cubic centimeters, and it's an interesting looking thing. I mean, already you can see that it's somewhat asymmetrical. That's something that we tend to associate more with us than we do with apes and such as that. That the area along the side here is expanded, or at least appears to be, and that's an area we call
you're
Broca's
referring to as Broca's area. Now that's the bit I'm using to speak to you.
That's exactly right. Well, at least that's one of the hypotheses of how that's using. And it has long been tied to the idea that if we were going to see a speaking hominid, we would see expansion in Broca's areas first. And you be the judge of that, whether that is. It's a brain that's not shaped like a hominid at 2 million years should be shaped like. It's a brain shaped in most of what we see superficially like something you'd see a little bit later, but with a few hangbacks of that.
It's small.
It's way too small. This brain could look like this and be double the size, and we'd be a lot happier. But also, I say that tongue-in-cheek, because to actually see something that really does look like a transitional fossil, that's something that's got bits and pieces of both sides of that fence, that's something that really is a rare thing in vertebrate paleontology. Often that sort of transition doesn't last for very long, and you don't necessarily really expect to find it in the fossil record. When you start seeing something that in so many different ways is bits of earlier things and bits of later things, it's actually really exciting.
How would that brain size compare with, say, the hobbits that were found in Flores, Homo floresiensis?
What an excellent question. Just a hair larger. Just a hair larger than the hobbit's brain, but not much. And one of the problems, of course, with the hobbits in Flores, one reason people criticized it was there was no good ancestor. We didn't have an ancestor that had that small of a brain with all these derived features of Homo in it that could possibly give rise to something like Flores until now.
So you could be looking at two things. One, the early evolution of language, and two, an explanation for where the hobbit people came from.
And there are even little things like this beaking at the front of the brain that might tie it very, very directly to that.
So we're now going to have to presumably go and look and find more examples, because presumably there's something downstream of this and upstream of the hobbits.
Oh, absolutely. But, maybe we've begun to put those pieces already together, because there are fossils coming out of Dmanisi in Georgia that no one could quite put. But they felt that they were a little bit too derived. But you're absolutely right. If this is, there must be something at 1.9, 1.8, 1.7, 1,800,000 that looks a lot like this and a lot like them.
And how old are the Dmanisi people in Georgia?
Dmanisi are 1.7 to 1.8.
So could these people have made it to Dmanisi by then? Presumably they could, couldn't they?
Absolutely, and they certainly have the lower limbs that look like they're capable of doing that for the first time. And a lot of people at first glance at these do recognize a lot of similarities between this and the Dmanisi. You can certainly have a good hypothesis of what kind of thing Dmanisi came from.
So you'll be chipping away to see what else is lurking here. How are you going to get the answers to these questions?
Well, the fact is, just at this site alone, I can tell you this, there's at least another 3 or 4 individuals, and we haven't dug yet. The site's big. There's no reason. It's a moment in time. It's not an extended period of time that these were collected over. One of the amazing things about this from a fossil perspective is that these individuals almost certainly knew each other. They died within hours, minutes, days, or weeks of each other.
Do you know how they died?
We don't know completely yet, but we will once we complete excavations. But already at this stage, there's some clues. If you look down here at the humeri, you can see the upper arms here. They're both broken in the same spot.
It's got a spiral fracture.
It's got a twist to it, which is indicating that happened at or near the time of death. And that's right at a very interesting point. That's right up near the neck of the humerus. That's, of course, the surgical neck of the humerus. The reason it's called that is that's where little old ladies break their arms whenever they fall and extend both hands out, and they fracture up there. And that's what you're seeing. And maybe that leads us to some clues that this individual, and there may be some other clues on other animals that are with them, took significant falls. We do know they were buried 30 to 50 meters down, and that's a very, very, very long way to fall.
So you think they fell down something, ended up perhaps, falling into a cave shaft, and then they got covered in sediment and this turned into concrete, and they were preserved? That's
pretty much the short story to it. They're not there alone. There's a saber-toothed cat that's with them. There's several antelope skeletons, a lot of mice, birds, insects, and they're all just as complete. And so whatever it was a death trap. Whatever it was a place where scavengers couldn't get to them. And whatever that was, it was attracting things that eat meat, that eat plants, and that eat both. And about the only thing that do that is water. And since they're all preserved in water, we can tell that from the geology, it's a good chance that this was some kind of vertical shaft that they were trying to get down to water.
The fact they were there together, was one trying to help the other one?
Well, we'd always like to get into that, but I doubt they were trying to help that saber-toothed cat. And I doubt that they were trying to, and the antelopes were trying to help them out. The fact that it's a mixed assemblage indicates there's something driving. And I think we forget. Us domesticated humans often forget how tough the world is. If I put you, Chris, up on top of a 30-meter flagpole that you couldn't climb down, and I gave you all the water you could drink, if I came back in 2 weeks, I'd find a believe it or not, skinnier Chris than exists here. Probably almost starving to death, but you'd still be up there. If I put you up there with all the food you can eat but no water, and I put a glass of water at the bottom of that flagpole, 48 to 72 hours later, I'd find you down at the bottom, no matter what.
One way or the other. Yeah.
One way or the other.
So you think that's probably what was going on?
I think that's a good guess at this time.
Can we just therefore put all this together and just explain for us how this fits into our understanding of the fossil record and what this adds? What's new here and where does this break the mold?
Well, I think for the first part, seeing all these bones associated with individuals, seeing these bones associated with animals that we can say that arm belonged to that leg, belonged to that pelvis, it's almost a first. You've got to remember that in the entire search for early human origins, there have been about 7 partial skeletons ever discovered. And so to see individuals and the various joints and parts of the body that relate, well, that's just something so special. It's something that will allow us to not guess often, but actually make real statements about proportions, about how they were interacting with the world. At the same time, we're seeing bones of unprecedented completeness. And that's a big thing. There's no guesswork when we put these pelvises together, when we put these rib cages together. That's a big thing. They also, if you had to pick a time for them to fall at, that 1.95 million year, well, that is the point where we move into that period, older than 2 million years, with Australopithecines, what are appropriately called ape men. They are bipedal apes with large, thick enamel dentition, very small brains, relatively primitive faces, generally long arms, and while their pelvises and legs were adapted to walking on 2 legs on the ground, they didn't do it the way we did. They weren't long-distance runners, they weren't striders, they weren't able to cover huge turf. Out the end of that, at about 1.7 million years or so, we see Homo erectus, our immediate ancestor, something that is a kissing cousin of ours. And it's that point in the middle which was the biggest gap we had in the fossil record. I mean, literally, you could take every fossil within 200,000 years of 1.9 million years, and you could put it onto a very small desk.
So they were either Homo erectus or it was Australopithecine, and there was nothing to explain how one became the other.
Except for a few fragments that we put in things like Homo habilis, Homo rudolfensis, or quote-unquote early Homo. Now we have a hominid that already, before we've even dug, we have one of the best records of a species. And at that critical moment, I'm not going to delve too much into what that's going to tell us because we are going to know that. And within the very near future, the next several months, the next year or two, this story will unravel at where these fit. They're at the right time. And it'll be interesting whether or not they are. Whatever they are, they're extraordinary.
So are they Homo or are they Australopithecine?
Well, we've called them Australopithecus, and we stand by that. Although anyone who watched the media debates would see that about half our colleagues said it's early Homo. The other half said, no, they're absolutely right, it's Australopithecus. We put them in Australopithecus because we felt that they had not made the grade level shift to our genus. We, in fact, in some ways think that this may be the Rosetta Stone to the definition of the genus Homo. And that is that we now know something that's almost there, but it's not. And if that stands, that definition stands, then we will then be able to identify what is. And what is frankly, at this time, Homo erectus, Neanderthals, and humans.
And what's been the impact on you of making this discovery?
Oh, it's changed every aspect of my life, Chris. This is what I dreamed of as an undergraduate sitting in Anthropology 101 watching slides of Lucy being discovered or hearing about Zinjanthropus or Homo habilis. I'm in a field where you do not make these discoveries. Most of us who do what I do go through their entire careers never finding a piece. To not only find a piece, but to find this level of contribution to science is moving and humbling. I'll tell you what it's made me realize, which had never happened with anything I'd been involved in, and I've found a lot of fossils in my career. You know for a fact that no matter how we interpret these fossils as a team, no matter what we make of them at this space and time, if human beings are still looking at themselves in 500 years, 1,000 years, 10,000 years, or 100,000 years from now, these have just become part of that iconic record. That skull that's looking at you right now will be a part of the visual imagery of the definition of humankind in our history, as sure as the sarcophagus of Tutankhamun or the painting of the Mona Lisa. And that is, it's something that, as a scientist, gives you pause.
And your son, how's he turned out as a result?
He's got
as
a lot
the discoverer.
He's got a lot of girlfriends at 12 years of age. He's a very zen young man, and he says he wants to be a paleoanthropologist. He's certainly enjoying it. And one of the interesting things, because of his involvement in this discovery, I think it has really stimulated children around the world. I mean, literally, we've received thousands and thousands and thousands of emails from children all over the world, suddenly stimulated in science and fossils and paleontology. And that's a fantastic thing to see embraced. It. But, I think I've taken a big lesson from this, and that is that there is a stage where you come to where you pretty much think all the cool stuff has already been discovered. And I'm certain that kids feel like that, certainly maybe in about February of 2008, I would have probably said, most of the really cool stuff in human origins has been found. We're going to stand on the shoulder of giants. We're going to add little bits and pieces of this information. And they're sitting right in the middle of the most explored area on this planet for early human origins, sticking out of the surface so easy to see that a 9-year-old could pick it up, was not only just another piece of these, but maybe the best things ever found of a completely unexpected new species. And what does that tell you about other areas of science? What does it tell you about what is out there to be found? Maybe the last 300 years have been the period where human beings have walked over every square inch of this planet. We may have set foot on every square inch of this planet. We may have, quote unquote, explored it, but we haven't understood what we were walking on. And maybe that's the gift that technology and the new generation of scientists will bring to the 21st century.
Lee Berger, who's a reader in evolution at the Institute for Human Evolution at the University of Witwatersrand in Johannesburg, South Africa.